Okay, let's make a start, shall we? Good evening, everyone. Welcome to week 2 of the SharePoint 2013 Development Short Course. My name again is Brian Farnhill, and this week we're going to be talking through developing for the SharePoint platform. So as usual, as with last week, if you guys have got any questions or comments or whatever during the lecture, please feel free to use the questions window and I'll endeavour to answer them as best I can as we go through. But let's get started, shall we? So what are we covering in this lecture? Beginning with tools and options for doing development with SharePoint. We're going to be going into some about data structures within SharePoint and how SharePoint actually stores our data. We're going to be talking about deployment options for customizations, so how we can go about getting our custom code and our custom solutions onto SharePoint. Options for cloud and provider-hosted deployments. So not just talking specifically on-premise, but what we can do in the world of Office 365 or other parties that are hosting SharePoint for us and how we can do solutions that can work with them. We're going to go into how we do debugging and logging in SharePoint solutions. We're going to do a bit of an overview around what a WSP package is and how that comes into play when we're deploying solutions and how we package our things up. We'll be doing a bit of a talk around what features are within SharePoint and how we can develop custom features to extend functionality of SharePoint. And we'll finish up with a bit around custom web templates and how we can create custom templates for sites within SharePoint. Okay, so the tools for building building SharePoint solutions. Number one on the list is Visual Studio 2012. So for doing SharePoint 2013 development, we're pretty much looking exclusively at Visual Studio 2012 because that's where the tools are for us to be working with SharePoint 2013. SharePoint 2010, we can use Visual Studio 2010 as well as Visual Studio 2012. And there's a couple of other tools that we'll be looking at from Microsoft's perspective as far as what we're going to need to be doing development inside of SharePoint. And the first one of those that I'd like to call out with SharePoint 2013 is what's called the Napa Office 365 development tools. Now, this is actually kind of cool in the fact that Napa is a web-based code editor that is essentially an app within Office 365 that you can use to create other apps, both apps for SharePoint and apps for Office, which are out of the scope of what we're doing here, but you can actually do those all within the developer site within Office 365. And the third sort of Microsoft tool that we'll talk about is SharePoint Designer. So SharePoint Designer, if you follow its history over these, used to be sort of evolved out of what was Front Page and became a more SharePoint-specific tool as we moved along. The 2013 release of SharePoint Designer has got has essentially had the design view removed from it. So the title Designer is a little bit misleading. It is just a code-only tool for the things that you're editing, like pages and things like that. But it still does have its visual editors for things like workflow designers and things like that. Questions come in is, can I mention the pros and cons of each IDE tool? So the pros and cons, it sort of comes down to the fact that so Visual Studio as an IDE is a very, very well-developed IDE, has been around for many, many years, and the tooling specifically around SharePoint development has also been through a few versions and revisions. The Napa tools for Office 365, this is their first release, and they are also based in a web browser, which is another fairly limiting factor. You don't get anywhere near the same richness of development environment, the same sets of templates or anything like that. But with the Napa tools, the fact that all I need is a web browser, I can pick it up and start writing code. It does make it sort of an accessible option for people who don't have access to Visual Studio. So third-party tools is another area that I like to talk about when I'm talking about tooling for SharePoint. And there are a few tools out there that I like to talk about. SharePoint Manager is an open source one, which is a brilliant little tool for being able to get a sort of nice hierarchical view of everything going inside of SharePoint and properties of objects and live settings and values out of your SharePoint environment. The Camel Query Builder, we'll talk more about Camel over the coming weeks. in that, so Camel is a collaborative application markup language, and is basically it's an XML-based format which is used throughout SharePoint for any number of things. We use it to define site templates, we use it to create data queries, we use it to define our features, things like that. But specifically for doing queries, the Camel Query Builder is a nice GUI for creating a query XML. The SharePoint Color Palette tool was technically released by Microsoft and is out there, but is sort of a standalone little tool for coming up with color schemes for SharePoint 2013. So it actually gives you a nice visual preview of what your sites can look like, and then you can save those color palettes and upload them into SharePoint to be able to have your custom color schemes applied. Fiddler is not even close to a SharePoint specific tool, but is a very useful one to have in your development environments nonetheless. Fiddler is essentially a web traffic listener. It acts as a proxy and lets you see requests that are going from your client to the server and back, which can be invaluable when you're trying to diagnose things like JavaScript calls, and being able to see exactly the calls and responses that are coming back from the server and what's going on in the browser there without trying to debug your way through various pieces of script. Power GUI is another one that I also am very much so in love with. It's a PowerShell editing tool. So one of the things that came out with SharePoint 2010's release was there was a lot of PowerShell integration and custom actions and whatnot within PowerShell that we could use to do all sorts of things. And needing to learn PowerShell as a replacement for the old STS-ADM tool became a bit of a necessity. So PowerShell is definitely the way forward from a command line administration point of view of SharePoint. But as developers, we're going to need to be knowing and working with PowerShell because of the fact that things like our deployment scripts are all going to be getting written inside of PowerShell, and we'll occasionally be looking at using PowerShell to gather information from SharePoint that we can use for debugging and diagnosing and troubleshooting and all sorts of things, really. So selecting the right tools for the job. Now, what we can do with SharePoint 2013, and I sort of briefly touched on this last week, is that we have this new model of doing apps in SharePoint. And I'm not going to go too deeply into exactly what an app is here because we've got the fourth week of this short course is focused specifically on apps. But basically an app, and it's the sort of one sentence answer, is just a HTML-based solution that can talk to SharePoint. So because we're coming back to using HTML as an open standard as such, we're no longer tied to .NET for solutions that are going to fit within the app model. So I could be going and creating a PHP-based application, for example, that as long as it's spitting out HTML and JavaScript, is going to be able to work with SharePoint just as tightly as something that was created in .NET and is hosted on iOS. So we can come back to being able to select whatever tools we feel are appropriate for the kind of development we're doing. We just come back to using these sort of open methods like REST, OData, OAuth, JavaScript, and HTML. The great thing with this is that it also means that the learning curve for doing SharePoint-specific development, at least as far as the apps are concerned, it does drop a fair bit because now there's far less specific knowledge you need to know about SharePoint to be able to get in and start doing some development. Now, I do still say that when I talk about not needing the SharePoint skills, it's not that you don't need them. It is still very much so the case that you're going to need to know how SharePoint is working and where you want to integrate into SharePoint and how SharePoint is storing data and working in the back end, and how your app is actually interacting with SharePoint as another application, essentially. It just means that some of the more hardcore things around the server-side code are less of an issue now, so it is definitely easier to become a SharePoint developer in SharePoint 2013 than it has been in previous versions. So what I want to do now is talk to the sort of structure of how things are stored within SharePoint. Now, I've been using the term a fair bit here of a SharePoint farm. Now, the question was asked last week of what is a farm in SharePoint. Essentially, the farm is one or more servers that are all connected to create a single instance of SharePoint. So the most high-level object that we're looking at in the world of SharePoint is the SharePoint farm. Now, within the farm, we can have any number of web applications. So a web application is an individual site that it has a URL and it has content under it, and users can browse to it. And our SharePoint farms can have a very large number of web applications or very few, but that's essentially that's the next object down from in our hierarchy here. Next below that is what's called site collections. So a site collection is, well, it's exactly what it sounds like. It's a collection of sites, but it's a way of grouping together sites within SharePoint, and there can be many site collections within a web app. There are a number of things that can be isolated down to a site collection level, which might create your need to use different site collections under a web app. So some web apps may have just a single site collection. Others can have many site collections. And there are all sorts of things like permissions, features, solutions that are deployed out there. There's a lot of things that are good reasons to have boundaries of different site collections within a specific web app. And of course, within the site collections, we can have many, many sites, which on their own actually form another hierarchy. So each site can have children's site below it, and then can have children's site below that, and so on and so forth, creating a hierarchy of these subsites. Now, looking at what's within an actual site, so drilling down further than that again. So our site is made up of any number of lists. Right, so this is one of the main data storage structures within SharePoint. Now, a list can be a sort of a table-like view of data of columns and items and things like that. It can be a document library, is essentially a type of list where documents are stored, and each row of data becomes a document. And so within these lists, we have multiple list items for being able to store data, which might be documents, it might just be textual data, they might have attachments on them. We can define all of the metadata that goes onto each item in the columns and things that are required. Just had a question come in. What is the best practice in separating site collections to individual web applications, e.g. the Document Center and Record Center site templates? So for things like that, a lot of your decisions are going to be fairly heavily influenced by business requirements and exact implementations, things like scale of how much content you've got to go into each individual site. But also there's probably a few usability concerns around the URLs that are in use and how many URLs users are going to be going to if you're doing multiple web apps. But generally speaking, when I'm talking about the difference between site collections and breaking them up, it's either a business decision or possibly a scale decision. One of the other things that you can separate a site collection out for is to move it to a separate content database. So I can have multiple content databases attached to a single web application and have some site collections in the first database and other site collections in another database, and as many databases as I feel the need to have. So this creates the ability for us to be able to scale things a little bit better, in that if I've got a site that is ridiculously huge, I might move it out to its own content database so it can be backed up and restored individually as it's its own database, where the rest of the sites in the collection might just run off a second one that is common. So those are the two sort of key areas that come up a lot for being able to separate where your specific site collections get separated within a web application. Okay, so moving on, we've got our sites, our lists, and our list items. So you can sort of start to see that there's a very hierarchical structure of data within SharePoint here, from the farm all the way down to the individual list item. Now, when we start talking about list items, we get to talk to content types. So every single list item within SharePoint has what's called a content type that identifies essentially the type of item it is. So yes, it's a list item, but is it a document? Is it a task? Is it a calendar event? These are all different content types within SharePoint. And so they basically use to identify the type of an item. It specifies the metadata and other settings to be used on the document. And so we can say that a specific content type has the following columns on there that users have to enter data for, and these ones are required, and these ones are optional, and these are dates, and these are text, and these are multi-line text, and we can specify all of these columns that get attached to our content types. We can include document templates for document-based content types. So if I've got a document-based one, I could be attaching a specific Word document as a template. So when somebody creates an item that is of my content type, they get my template as well, which is great for if you've got Word-based forms or document templates for your organization, you can include those templates inside of SharePoint, and when the user says, I want this particular document, they get your template. And the great thing with content types is that they're a hierarchical structure as well, and they will inherit from their parents. So we can look at this as sort of like when we're creating objects in code and we're inheriting from parent objects. We get all of the properties and methods of the parent object. The content types behave in a similar way, in that if I inherit from a top-level content type, I will inherit all of its metadata and its default settings as well, and that then flows down the chain. So if I add a particular column of metadata to a top-level content type, it can then be pushed out to all the children content types below it. So content type inheritance sort of looks a little bit like this, in that everything in SharePoint inherits from what's called this system item, and the one content type that hangs off that is item. So if you create a custom list inside of SharePoint somewhere, it will have a content type in there by default that is just called item, and you say there's a new item. Below item, there's a number of content types out of the box. There's document, for example. So a document is a type of item. It's the child of item. But other things like tasks or events, for example, they both inherit from item. Below that is, so say below document, for example, and this is just a subset to demonstrate the concept. This is by no means a comprehensive list. But below document, in the web content management space, we have what's called page. And then below that, we have article page. So we have this sort of hierarchical structure where columns get added at the top level and flow all the way down. So for example, the title column is the one piece of metadata that is attached to the item content type. That means every single item that it inherits from it, no matter how far down the tree is, will have a field called title. And then documents start to add a few other fields as well, like modified by, when it was modified, who created it, and the date it was created, and some document-specific fields. Tasks will have percentage completed, who it's assigned to. Calendar events will have start and end dates, that sort of thing. They all have metadata specific to what they are, and then children content types can go and inherit from those. Question, what tool can we use to manage content type inheritance? So content type inheritance. So you can look at the structure of content types through the user interface, and I'll go through that at the end of the slides here and show you how that's done. And you can see the structure of the content types. The other thing that you can use to identify the structure of content types sort of leads into my next slide here, which is around content type IDs. So the content types are one of the only items inside of SharePoint that aren't uniquely identified by a GUID. They have this content type ID structure, which in and of itself is designed to be able to show you exactly the structure of a content type just by looking at the ID. So the system item, that root level item, its ID is 0x. So because everything ultimately inherits from that, every single content type ID within all of SharePoint will always start with 0x. The item, so the next level down, its content type ID is 01. So combined with the system item, you get 0x01. Then looking below that, we have document, which has 01 on the end of that again. So 01 is its identifier. And looking at task and event, you can see they've got 08 and 02, and the way that they combine to create a complete content type identifier. So 0x0108 is task. So looking a little bit further down, and you see that under document we have our system page and we have our page. The extras that are added on here are a little bit longer. So basically the way a content type ID is made up is it's one of two ways. Either the first option is 2 hexadecimal characters. So in this case the 01s and 08 and 02, they're the 2 hexadecimal characters that represent that individual item. The second way of doing this is to add 2 zeros and then a GUID. So you take all the punctuation, like the dashes and the brackets, off the GUID, and you strap it together there, and you end up with 00 GUID as being the unique identifier for that particular type. So by the time you get down to the page content type, for example, you can see that it is actually quite a long number. But you can look at it and find the 00s as the identifiers for the breakpoints of each level, essentially, and then start to get a feel for the exact structure of the content type based on its IDs. Aren't content type IDs customizable? Yes, content type IDs are customizable through development. So through the user interface, you'll actually get the big long GUID versions whenever you create custom content types. If we're creating them through code, we can use just the two hex character option of being able to push those numbers in. And the thing to be wary of there is that a lot of the out-of-the-box content type IDs will do that, so just make sure that you're not stepping on the toes of an out-of-the-box content type when you're doing it that way. More often than not, when I'm doing development, I do stick to the GUID one, just purely for ensuring absolute uniqueness of my content type IDs. Another question, isn't that just C hex notation? I'll be honest with you, I'm not familiar with C hex notation, so possibly, but I can look that one up later. And are there any third-party tools to help visualize this inheritance of structure? I don't know of any that will show you the inheritance of structure of a content type. There might be something out there, but I will take that one on notice and do some looking around to see if I can find a tool for that. Okay, so getting into some of the API-specific stuff now, and looking at some of the objects that we're going to be able to use from the API point of view. So we've got our concept of our hierarchy with our farm, our web app, site collections, sites, lists and list items, drilling down through there. Looking at the server-side API, which is where we're going to be doing most of our work across this short course, but I'm including some of the client-side and JavaScript options for anyone who's looking at the Office 365 stuff. Everything on the server-side API lives inside of Microsoft.SharePoint as a namespace. So we have SP Farm, we have SP Web Application. The site collection is called an SP Site, and a site is called an SP Web. That is one tricky thing to sort of keep in mind when you're trying to talk, particularly as with a developer knowledge, talking to business users. They say site collection, they say site, but developers will say site and web. So it is a little bit of ambiguity around the term site there and where it applies, but SP Site is the object for site collection, and SP Web is the object for a site within that site collection. A list within a site comes out as SP List, and your list item comes out as SP List Item. So most of the server-side objects all start with that SP prefix, despite the fact that they're all inside of a namespace called Microsoft.SharePoint. That little thing there was actually sort of addressed in the client-side and JavaScript object models, where they drop that SP prefix. So looking at your site, your web, your list item all under that client namespace. It is worth noting the absence of the farm and the web application objects in the client and JavaScript object models. Because these object models are designed to run away from the server, they're essentially built in a way where you shouldn't need to be touching the web application. You shouldn't need to be touching the farm for what's going to be done in client-side code. Anything that needs to interact with that level of object has to run on the server itself. So those objects exist only in the server object model. But yeah, and then the JavaScript stuff, you've got your SP Site, your SP Web, your SP List, and your SP.List Item. So sort of familiar naming of objects across all of them, just with or without that SP at the start of the object name if you're on the server-side object model. So basic API use. Oops, there we go. This is just a really, really simple example. So basically one of the ways that we can interact with SharePoint, one of the more common things that we'll be doing when we're writing code is connecting to a SharePoint site and then doing something with it. We'll be getting data out, we'll be pushing data in, we could be changing settings. So this is going to require working with the SP Site and SP Web objects. Sorry, questions just come in. So the server-side API is using ASP.NET. Yes, everything to do with SharePoint is based on ASP.NET. So our example here is we are creating the new SP Site object. So there's a few different constructors on the SP Site. The most basic one is to just give it the URL of the site that you're looking for. So in this case, I'm looking for my blog site. Now, in the case where you're passing in a URL here that is for a specific site and not a site collection. So in this case, if you were looking at my demo site collection backup from last week, the blog site was just a subsite of my main publishing site. What will happen here is SharePoint will actually figure out which site collection my specific site is in, and that will be the SP site that is returned. The next line in the using statement there is being able to open the web object. All right, so the open web method will get me either the root of the site collection, if that was the URL that I passed into it, or it will get me the specific SP web for the full URL that I've passed in. So in this case, I'm going to get my blog site back. And basically from there, we can go and do whatever we need to. So we've got our site object, we've got our web object. I could from here drill down and do things with lists or list items or any of the settings within those, that specific site or site collection. So another example here would be iterating through all of the lists. So in this case, I'm going through my lists property of the SP web object, just basic for each loop, and pumping out the names of the lists. All right, so we can have as many lists in a site as we feel like putting in, and we can iterate back through them all like that. There's another example here of being able to get a specific list. So here we have a list called sample list, and I've got my items that I'm pulling out and going through a for each loop there. Question that's just come in is, can I demonstrate this in SharePoint? Yes, that's going to be in my demo at the end. Also, I'm writing in the var object, don't I need to typecast it? So there are a couple of scenarios where you need to typecast specifically. In C#, it's generally inferred from the actual object that's in the value. So where I say var list equals web.lists, the compiler knows that that's actually going to return an SP list object, so I don't necessarily need to typecast it. You will notice, though, that in the for each loop that I have below here with the list items, I have specified SP list item in there. Generally, the for each loops are the ones that seem to get a little bit stuck as far as typecasting go, and if you don't specify the list item, the object type there for SP list item in this case, I miss out on having those properties when I'm trying to iterate through my objects. But for the most part, you don't need to specifically label the types of the objects. There is one other thing I want to call out in this particular example of code here is that you see that I'm getting items as list.items and then iterating through my local items variable rather than just putting list.items into the for each loop. There are a few things like this throughout SharePoint, and there's a lot of articles on OSDN that can sort of explain some of these little tricks where performance can be affected based on how we call our code. So by calling list.items out here and creating a variable locally, what's actually happening is SharePoint's going to go do a database query, pull all of my objects back and bring them back into that items variable there. If I put items into that, so list.items into the for each loop directly, what would happen is for every item that SharePoint went to pull out, it would then do a unique set of database queries for that item rather than one for the whole list. Now, the problem with that is that you end up with a lot of overhead on your SQL server that way, and it can dramatically affect performance, particularly in large lists. So there are a few things like that, and I'll call them out as we go through, where they're worth highlighting that you will need to be aware of from a sort of best practices point of view of writing your code. There's also a few other tools around provided by Microsoft, and that will be able to integrate into things like your FXCOP for checking out code structures and things like that and validating your code. Yes, there's an example there. Are these examples client-side console code? So what I've got here is technically server-side, but it is a console application. So, and you'll see examples of this in my demo at the end. But you can create a console app that is designed to run on the server itself rather than running remotely to SharePoint. So this is still referencing the main Microsoft.SharePoint DLL, which is on the server itself. So will require running from the server. You can reference the .NET client-side object model for a console app that's going to run remotely, but you will miss out on things like those farm objects, the web application objects, and anything that's not designed to run down through the client side. The client-side code also has a lot of intricacies to it in that you need to be able to run a lot of methods asynchronously and wait on results. So whereas in this particular one, I can just say, give me the list, give me the items, and let me iterate through it. On the client-side one, I might say, get me the items, and then wait on the return method there before I can iterate through them. So it runs as a truly asynchronous piece of code rather than a sequential piece like this. Would the debug need to occur physically on the SP server or from a client machine? We'll get into the debugging stuff a little bit later, but basically if I'm debugging server-side code, I'm running Visual Studio on the server, so on my test environment, and debugging that way. You can use the remote debugging tools within Visual Studio if you've got those available to you and connect to the SharePoint server remotely from Visual Studio. But generally speaking, in a development scenario, if I'm writing server-side code, I'm debugging on the server. Next question is, presume the complexities of client-side authentication is not the same for server-side. Yes, this is absolutely the case. So when I'm running server-side code, my code will execute as whatever the current user context is. So in the case of this example here, where it's a console app, it will run with the credentials of the current user that's actually running that console app. In the context of things like a web part or something within the web browser, it will run within the context of whoever the current user is. So we don't need to worry about authentication for server-side code. It gets managed for us. Next question there was, does IntelliSense work for these namespaces? Absolutely. There's complete IntelliSense for the server-side object models and the client object models. And when you're doing app development, you can even add references to the JavaScript files and get IntelliSense on all the JavaScript object model stuff as well. So it's all completely there supported within Visual Studio. So one of the things you also may have noticed about my examples there were that my SP site and my SP web objects were inside using statements. So the using statement came into C# a couple of versions ago and hangs off an interface called iDisposable, which basically is a way of saying that when you're done with an object, run this dispose method to clean it up. So there are a few objects throughout the SharePoint object model on the server side, and this disposal generally applies to the server side only, where if you do not dispose of the objects, you will end up with some reasonably heavy memory leaks. So using SP Site and SP Web inside of the using statement will make sure that your code tells the .NET garbage collector that it needs to be able to go and clean up specific parts of those objects and free up that memory. By not doing this, you're going to end up with memory leaks in your iOS worker processes, and they are going to get to a point where they just stop responding until you recycle the application pools. There are some tools out there, and the main one that I like to talk about is SP Dispose Check that can help you identify these issues in code. Now, I haven't actually had any success using SP Dispose Check against SharePoint 2013 with .NET 4 code. But everything up to 3.5, it works fantastically for, and I'm going to demonstrate that a little bit later on. But it will actually pull apart your code, your compiled code, so it's not looking at the raw source code, and it will identify where there are objects that could potentially cause memory leaks, so you can go in and investigate it. There is some very good documentation on MSDN as well, and a couple of articles are in the links for tonight's lecture that will also explain this in a lot more detail for you and the exact scenarios where you do and don't need to dispose of objects. This type of thing is one of the things that made sort of getting around SharePoint development a little bit harder in previous versions. As you know, especially back in SharePoint 2007, it really wasn't that well documented at all. It sort of throughout 2007's life cycle, and particularly in 2010, got a lot of exposure. And there's also some third-party products out there which will integrate into Visual Studio to automate the process of doing this disposal check when you're doing things like builds, or even including it into a team build process in Visual Studio in TFS, sorry, so that you can have it fail a build if there's detected memory leaks. So the question I've got here is, are my examples on ASP.NET 4? So those examples that I've been running through here are all, well, they're all .NET generic, basically. Like, it's exactly the same code for what I've been showing in the slides as I've used in .NET 3. The code that I've published is all targeting .NET 4. So there, if you've already had a look at the site where we're tracking all of the content for this, and alongside all the links and the slides, I've got a version of the code that I've zipped up and put there. And there's also a link to a GitHub repository if you're a fan of GitHub, to just take a fork of the code and keep an eye on it from there. But it is all targeting .NET 4. Okay, so solution packages. When we're finished writing our code for SharePoint and we're ready to push it out, the solution package is how we get our code onto a server. So it's custom code gets packaged into these solutions. They're a WSP file. So it's a common file type that you'll hear a lot when you're talking about SharePoint development. Essentially, a WSP file at its core is nothing more than just a cab file with a different file extension. And inside of that, you can look at all the individual files that are going to get pushed out to your server, along with a couple of XML-based manifests that will tell SharePoint, what files are in this package and where they need to go and what it needs to do. The old way of being able to create these back in SharePoint 2007 as well was basically calling makecab.exe directly and creating a cab file based on your folder structure. Thankfully, the tools have upgraded over the years, and looking at Visual Studio 2012, we get a native WSP build directly from Visual Studio. How are we deploying solutions? There's a couple of options. We can deploy them to the server directly. This is known as a farm solution. Right? So you'll hear me use these two terms a fair bit. The farm solution is for on-premise deployments and is basically designed to deploy something for the entire farm. You can also deploy a solution to a site collection by uploading it into a site collection through the user interface. And this is called a Sandbox solution. I'll talk more about them a little bit later in the lecture. So what goes inside of a solution package? So the most important part is an XML file that is your manifest. So this tells SharePoint everything it needs to know about your particular solution. It's going to tell it what type of solution it is. Is it targeting the GAC? Is it targeting the IIS folder? What features have been created and gone in here? What particular namespaces should be trusted for controls to be rendered in the web browser? Are there any CAS policies that get deployed with the solution and where they are within the package? Everything about what's inside the WSP file gets documented inside of that manifest file. So feature directories in the XML files, the actual assemblies themselves get thrown in here. So our DLLs that we're creating will be inside of the packages as well. And we can also include resource files if we're doing localization of our solutions. And we can include those in our WSP packages so that they get pushed out as well. So how do we actually deploy solutions? So the first option, the one that should be the main one that we look at, is PowerShell. So there's two different options here depending on how you would like to target. You can use the add SP solution call to deploy a farm solution, or you can use the add SP user solution for pushing out a sandbox solution. So we can do both of them via PowerShell. The old STS-ADM command line is still around for doing farm solutions. So STS-ADM used to be the way that we worked with, like scripts and command line based activities within SharePoint. I don't believe it's officially deprecated, but the advice that's been coming out since SharePoint 2010 was released was to start getting your head around PowerShell, because there wasn't going to be anything new added to STS-ADM. It was all going to be added to PowerShell exclusively. So any of that sort of thing, I wouldn't rely on using STS-ADM going forward, but it is there and it is an option. And last but not least, for the Sandbox solutions, as I mentioned before, we can upload them directly into the solution gallery in our site collection. Question that's come in is, what is the best practice for change management of deployment with WSP packages? i.e., can I do a rollback on the deployment if it fails in production? There's probably a whole other lecture I could do on how you're going to be able to version WSP packages and things like this. Generally speaking, there's not a massive amount of support for being able to do versioning of WSPs outside of the fact that a common approach is you might actually put a version number onto your actual WSP files. So I might have my solution 1.0.WSP as a file, and when I upload that, it pushes all my files out. Then if I create 1.1, and I would call it 1.1.WSP, and when I push that onto the server, it will overwrite the files that were deployed by 1.0. So in the scenario that something horrible went wrong and I needed to pull it back out, is I could retract that solution for 1.1 and tell it to redeploy the 1.0 solution to get all the files back out onto the server. Generally speaking, though, it has been a sort of issue that a lot of people have had to try to address over the years with SharePoint development, is how you get around that versioning thing. And depending on the types of customizations you're building, it is going to sort of vary from particular solution to solution and developer to developer as well. Another question is, can I clarify the difference between a solution and a web part? So a web part is a type of code, a type of customization that we can do, and the solution is the deployment mechanism in this case. So a web part can be packaged up inside of a solution and deployed to SharePoint. So updating solutions. So fairly similar set of commands for being able to go and do updates. Again, we've got our PowerShell methods for being able to trigger updates for Farm and Sandbox Solutions. We have STS-ADM available, and we also have the user interface available again for the Sandbox Solutions. So pretty much just swap add for update, and it is more or less the same process. Now, Sandbox Solutions I've mentioned a couple of times tonight already. Sandbox Solutions was a new feature of SharePoint 2010, and it was essentially designed to let you create a code that would be able to be uploaded by a user rather than going through an administrator at the back end into a site collection and provide you with some sort of functionality. The obvious reason that Microsoft went and put this in was to try to enhance the development story around what was happening with Office 365 and SharePoint 2010, in that you pretty much had no development options if you were looking at moving to the cloud with Office 365 for the 2010 release. So Sandbox Solutions was a way around that. Essentially, the way the Sandbox stuff works is that the code itself is executed into an isolated worker process and only has very limited access to the object models and the .NET framework. So what you can do in a Sandbox solution was very, very, very limited compared to what you could be doing for a farm solution. Despite the fact that they're both WSP files, they're both compiled .NET, they both had a lot of similarities between them. It was that execution model that made the difference, in that the Sandbox thing would limit it. It would manage resources on it. It would make sure that if you wrote code that was very resource hungry, it could monitor that, report on it to an administrator, and provide a way to essentially cut your solution off. So. But it was a nice option for getting some minor customizations built for Office 365, and particularly if you had minor things that you could roll in without necessarily needing to get your administrators involved in the whole process. It was an attractive option in theory. There were a bunch of administrative options as well around being able to set rules for how many resources solutions could use. You could also blacklist solutions as well, so if your administrators found out that there were dodgy things going in, they had the ability to be able to squash that and control it. But essentially it was this theory of create a solution that didn't depend on deploying anything to the file system. So in the context of a farm solution, when we deploy our farm solutions onto SharePoint, it actually unpacks that cab file, and it will take copies of the files inside it and push it out directly to the file system on the server, like straight down the C drive. Whereas a Sandbox solution is stored exclusively within the content database. So the main thing here is that if we were pushing things down to the file system, it was not really a model that was ever going to work well in a multi-tenanted scenario like Office 365, where you could have any number of tenants all using the same server at once and having their customizations essentially stepping on top of each other if they used the same file names, or having that level of access to execute code on the server could put the server under heavy load for one person's bad code that could have, say, memory leaks in it that would then affect a number of other tenants that were essentially innocent victims. So the Sandbox Solutions was the 2010 way around that. Sandbox Solutions do still exist in SharePoint 2013 and are still there and alive, but the preferred model with SharePoint 2013 is the new app model and code that doesn't actually execute on the SharePoint server itself. Again, I won't go into it too much in this lecture because we've got week 4 for it. But if I'm starting a solution now and I'm looking for doing it for a cloud-based solution for SharePoint 2013, I'm very much so looking at app development ahead of Sandbox development. So when we get into Visual Studio and we start looking at creating a project, there's a few different project types we get when we say create a new project. We get our empty solution, we get a Silverlight web part, we get a visual web part, we get the option to import a solution package or import a reusable workflow. Now these are all fairly generic and high level, and there's a bunch more specific items that you can add to a project once you've created it. But these are the options you're going to get when you say create a new project inside of Visual Studio. The Silverlight web part is still there, but for anyone who missed the news on Silverlight, it's basically not getting updated or supported past, I think it's 2025 is the year that they're officially cutting off support for it. But as a development platform, I would not be creating any great investments in Silverlight at the moment because it's already been flagged as something that's being retired. The visual web part we'll go into more detail in next week when we're focusing on web part development. But there's a couple other interesting ones here. The import solution package lets us take a WSP file and bring it into Visual Studio and create a new solution based on its contents. And the reusable workflow option is a way of exporting a specific type of workflow that you've created through SharePoint Designer and being able to take that out and bring it into Visual Studio to extend it beyond what you're able to do inside of SharePoint Designer. Question there is when would you or wouldn't you develop in the sandbox, i.e. is there less options at design time with a sandbox solution versus an app solution? So the difference between sandboxes and apps is going to be fairly different in that your app solutions are all going to be targeting client-side technologies like your JavaScript and your remote development, whereas Sandbox, you are still technically running on the server, you're just running on a very cut-down model of the API. As I mentioned on the previous slide as we were sort of walking out there, is that I would not be creating any new Sandbox solutions unless there was something that I couldn't do in an app. And from what I've seen in the app model with the APIs and what's available to us, there is not a lot that isn't going to be able to be done in an app for stuff that gets triggered remotely. At least, yeah, things that you can do in an app that you wouldn't be able to do in an app, that you would be able to do in the sandbox. I can't think of too many items in that scenario off the top of my head. So yeah, 2010 the option was there for the sandbox, but with 2013 the app development is a much better story to begin with, I believe. SharePoint features. So this is another term that I've used a few times this evening, in that features are something that we can push out into our solutions, and they're a way of extending SharePoint. So a feature at its heart is essentially a discrete unit of custom functionality that we can apply to SharePoint at some level. A feature can apply to a site or a site collection or to a web application or even to the whole farm, depending on exactly what you're doing in that feature. It can do all sorts of things to extend SharePoint, and there's a whole segment of the Camel markup language there, which is dedicated to defining features and the options there. But it is all just XML files that tell SharePoint, go and do something at this particular scope, being the farm, the web app, the site collection, or the site. Now, what can a feature include? A feature can include lots and lots of stuff. We can do things like deploying custom content types. We can do delegate controls, which we'll get touched on later. We can push out document converters, event handlers, and custom code for those. We can do list definitions and instances of lists and push data into those lists. We can do just content files that need to be pushed into a site. I can create custom columns that can be used inside of content types. I can push out workflows. I can do site templates. I can have just custom activation code on the feature so that when the user turns the feature on, some of my code runs. It is quite a flexible model for what we can do within SharePoint, particularly when we come down to doing site templates and looking at a template as being nothing more than a collection of these features to say that this site is made up of the following features, and that defines what the site is and what it does, the things that go into the site. And I will hopefully be able to demonstrate this a bit better in the actual demo as opposed to this discussion here. But features for server-side development is a very key component and something you'll become very familiar with when you're doing server-side solutions. Okay, so compiling is fairly straightforward. Visual Studio does all the heavy work for us, and as I mentioned earlier, it will also create the WSP package for us. So we get our DLL, our standard .NET framework DLL, and the WSP package will contain that library as well as any other resources like XML files and features and folders and things like that, and we'll see these in the demo. They all get included inside of that WSP package as well, so it's ready to go. So debugging of SharePoint solutions. So as we're writing them, we now have since SharePoint 2010, have the ability to just press F5 and deploy locally and have it automatically attach the debugger for us. and then after that, it's just the same as debugging through any other ASP.NET application. If you like, you can manually attach the debugger. So the processes that you're going to look for are the w3wp.exe. This is the IIS worker process. Now, depending on the number of application pools you have running on your SharePoint server, there may be multiple instances of the worker process running. You can generally identify them by which service account is running them, or if need be, the lazy option is you can just attach to all 4 or 5 of them, or however many there is. OWS timer is another process that you may find yourself occasionally attaching to. SharePoint has an inbuilt timer service which runs all sorts of things at regular intervals throughout the minute, the day, the week, the hour, whatever. They can run at all sorts of intervals, and if you've got custom timer jobs, or if you're looking at workflows that are hanging off particular events in some cases, OWS timer is where your code will actually be executed rather than within the worker process. Question that's just come in is, do you need to create a setup.exe to deploy applications? No, you do not. A SharePoint package, so your WSP file, is deployed using those commands that I mentioned earlier, so the PowerShell commands. So if I'm creating a custom server-side solution, what I'm handing over to the IT guys to deploy is a WSP package and a PowerShell script that will deploy my WSP and then create whatever sites and structure and content I need and turning on features I need and things like that. But it doesn't get packaged up into a setup.exe, no. The main reason for that is a setup.exe is more about pushing files onto the current server that you're running on. Whereas in the case of SharePoint, our customizations might be getting deployed out across multiple servers. I might have a farm of 1 server, I might have a farm of 32 servers. What SharePoint will do when we trigger the add SP solution PowerShell command and we add our WSP in, is it will automatically put copies of those files out on every single server in the farm for me, so I don't need to go and run it 32 times. The beauty of this is that if we go and change our architecture of our farms later on and we add servers, we take servers out or we repurpose them, it will automatically push files onto the file systems based on the solutions that have been deployed. So I know that when my solution is there, it's going to be everywhere it needs to be, and I don't need to worry about installing software on individual servers in the farm. The developer dashboard. So this got added in SharePoint 2010 and essentially was a way that through the web browser you could assess a lot of information to do with a specific request. So we could look at things like what were the SQL queries that got executed, what was the load time, what were any errors that were worth flagging, were there custom messages that were pumped out by any of our code. And in 2010 it actually ran at the bottom of the page when it was turned on and gave you all this fantastic diagnostic information which can help in troubleshooting specific issues with things that we're developing. In SharePoint 2013 it's actually been turned into a little pop-up window, and it will actually listen to all of the requests that are going on from the parent, and this is great because it'll actually listen in on a bunch of JavaScript requests as well and let us see all the individual sub-requests that come from our main request to load a page. But it gives us access to things like all the log messages for a particular request, all the SQL details again, all the performance details, and we'll go through this in the demo and show it, but it is a very useful tool. It basically gets turned on through a couple of lines of PowerShell, which are on this slide here, and we can just turn the developer dashboard to on. While it's turned on, what will happen is, you see my little screenshot below there, you'll see that little sort of Diagnostic Heartbeat looking icon on the right-hand side. That icon will appear once we've run this PowerShell script. It will not be visible beforehand. When you click that, it'll open the pop-up window and the developer dashboard will begin doing its thing. I haven't seen a way to turn the developer dashboard on inside of Office 365 yet. Looking at what it's been done with it in the 2013 version is it does stand to reason that it looks like it was designed very much so to be able to run in the cloud, but there are a few things that I think need to be taken care of in the back end before it's something that's ready to go out to people. So it's not in 365 yet, but fingers crossed it will be one day. Logging inside of SharePoint. So one of the acronyms you'll hear a lot when talking about logging inside of SharePoint is ULS. All right, so this is the Unified Logging System of SharePoint. Basically, it is a very, very verbose text file with a lot of information about every time SharePoint does anything. the log files that it generates are specific to a server. So in a farm scenario where I have multiple web front ends, for example, logs can be happening down to each of those servers individually, and in some cases will be necessary to gather logs from more than one server to diagnose an issue. But they are very, very heavy and very hard to look at. So there's been a few people develop tools, and Microsoft have done one called ULS Viewer, which gives you a really nice way to watch your log file live as it's happening, but also filter it down to any number of criteria to make it easier to pick out specific events from the logs that you're going to want to be aware of when trying to troubleshoot a specific issue. We also have the ability to log custom code to the ULS, and this is generally the preferred way of doing logging inside of SharePoint, is to add your own logs back out to the ULS and work within the realms of what's going on there. So in this little code snippet here, you can see that I'm referring to spdiagnosticservice.local to get the local instance of the diagnostics log. The local property there is just a static member, which will grab the current one for me based on the context that I'm running in for server-side code. The rest of it here, you can see the main thing I'm calling out here is my diagnostic service.writeTrace. And this is how I dump my trace messages out to the log. And I can specify things like the severity and the area that it came from and things like that. The logs themselves, as far as what gets recorded, can be managed by an administrator to say catch it at a specific level, being verbose or being very high level informational messages and anywhere in between. So by specifying appropriate severity on our custom code, we can include them and fall in line of that same logging framework that is there within SharePoint. It is worth noticing that for client applications, we're not logging into the ULS at all. So there's no way to pump messages down to the ULS for code that's running outside of SharePoint. In that case, we're going to look for our regular logging methods for .NET applications and taking on board any of those depending on your particular logging preferences. So site definitions inside of SharePoint is another thing I want to talk about quickly here, is that they're the old way to create sites. So when you're using SharePoint and you go and say, I want a new site collection or I want a new site, and you see all of those out-of-the-box options for blog site, publishing site, team site, these are all based off what's called a site definition. A site definition is an XML file that's deployed onto the file system itself, and defines a set of content for what goes into a specific site. What features get turned on for it, what pages get deployed for it, what are the settings of this site, things like master page URLs, that sort of thing. And they can, up until SharePoint 2007 in particular, they were the main way of saying, well, let's create an extension for SharePoint and give it a site definition. Now, traditionally, they can cause issues around upgrades, and this is one of the reasons why I say these are the old way of doing things, in that if Microsoft go and create another version of SharePoint and say, yep, upgrade your sites and you'll get this new functionality. If I'm based on one of the out-of-the-box templates like Team Site, for example, I'm going to get whatever new functions were put into Team Site in that next version. Whereas with a custom site definition, it's entirely up to me to go through and test everything and make sure it works and push it all up and add in any other functionality that comes in release to release. The better way of doing this is done through what's called a site template. All right, so not a site definition, but a site template. Site templates are based inside of features, so they can be deployed into the sandbox. Right? There's nothing actually going locally to the file system in this case. And they essentially inherit from an out-of-the-box template, and then you can add to them and extend on them. So at the very base level, I will start with inheriting from the blank site definition for my template and add to it. But I might find one of the out-of-the-box ones that's fairly close to what I'm trying to deliver, and say I'm going to inherit from that and add the following. And so we start to build on top of these out-of-the-box ones. Now, the benefit there is that when the upgrade goes through, the site is still based on one of the out-of-the-box definitions. It's just had your extra stuff tacked onto it, which makes the story from an upgrade perspective much more palatable in that you're not going to have as much effort and testing required to verify that your stuff still works. The actual structure of a site template versus a definition is very, very similar. They are still based on the same type of XML file. And one of the things we can actually do to get a site template inside of SharePoint is actually generate it through a Save as Template link on the site settings page. So an even easier way to create these rather than doing it all by hand is to build it all through the web browser and get it working the way we want, and then simply export it and open that up inside of Visual Studio, where we can apply any final tweaks or whatever we want onto that. So just wrapping up the run through of the lecture here. We went over some of the tools. We talked about data structures within SharePoint. We went over some of the deployment options and how we can deploy them. We talked about what can work in the cloud and provider-hosted stuff in the way of Sandbox Solutions. We quickly talked about debugging and logging. Had a quick overview of what goes into a WSP package, what features are, and just touched very briefly on what web templates and site definitions are. So what I'm going to do now is I'm going to switch over to some demo and actually show you guys some of these concepts. Okay, so looking very quickly at my my SharePoint site here, wanting to find out how these things are structured from the hierarchy that I was discussing earlier. What I've got here is I've got my site collection that I created within my web app, and if I come into viewing all site contents, down the bottom here you can see I've got subsites. So these are sites within my site collection. So they're all hanging off that site collection object. Looking at things like content types in particular, if I come into site settings and go to site content types here, for some reason that's throwing a blank screen at me. Thank you, SharePoint. What you would normally expect to see in here is a bunch of content types. But for some reason this site has decided it doesn't want to work for me, so I'm going to flick over to my Office 365 one and demo it from here. So if I come into Site Settings and Site Content Types, you see I've got a collection of content types. They're all grouped by categories here, but if I come down here under List Content Types, you'll see here item. So this is that top level item content type that pretty much everything in SharePoint inherits from. When we're looking at a content type, it tells us its name, description, what its parent content type is. So in this case, the item one inherits directly from that system item, like I mentioned in the slides. And I can see columns that apply to this. Here is the title is the one field that applies to item, for example. I can now move down and have a look at documents. If I go and find that. Documents, yep, going past it there. So coming down here, looking at some of the other ones, event, for example. So this inherits from item, like I mentioned before, but you'll see it's also now got a bunch of extra fields on it, location, start time, end time, and you can see the source of each of these columns. So item is the source of the title field. So you can build up this rich level of inheritance of columns and metadata onto these individual content types. So then when I go out to a list, so if I come back into my site settings here, my site content. All right, I could come into my document library, for example, and into the library settings, we can go and turn on management of content types. So this allows me to select which content types I want to appear in this document library. So at the moment it's got just the out-of-the-box document one, but I can go and add any of the existing content types in here. So then when I add a document, I get to say it's this type of document, and based on that I will have things like template and metadata predetermined for me. Question has just come in. I noticed that it uses ASPX. Can you access SharePoint with REST services only when you create custom apps? So REST services are built into SharePoint 2013 and are something that we'll cover in week 4 in the app specific session. But it's not just a client thing. It is just an open implementation of REST services and OAuth that you can use if you want to go down that path. Okay, so there's just a little bit of a view of how the content types tie into document libraries and things like that. Now, features is another thing. So let's flick back into my site here and back to my intranet. if I come into my site settings, you'll see under Site Collection Administration, I have this link here that says Site Collection Features. So here is a list of out-of-the-box features that are set to target the site collection scope, and will basically, I can turn them on or off in this particular site. Now, when you create sites off a specific template, specific features can be turned on or off, and we'll go through how that's done in the site template stuff. But I can go and turn on individual things like SharePoint 2007 workflows if that was what I needed, or the search engine site map feature. I can turn that on so that way anonymous access can be made to a site map that SharePoint generates. There's a lot of them there, and we can build custom ones into this that can be turned on or off by users or by our site definitions to add functionality into our sites. Now, let's have a walk through inside of Visual Studio. So if I go and open up a new Visual Studio window here, and say I want to create a new project. So once we've got all our tools installed under the Office and SharePoint tab here, I can come into Apps for SharePoint, which we'll go over in week 4, or SharePoint Solutions. So I've got a range of 2013 solutions here, and also a range of 2010 solutions, so we can work with both of them from here. But there's the types that I mentioned, and I can create a new project and go through this wizard here, which is going to define how my solution should work. So the first question is, what is the URL that I'm going to use for debugging? So this isn't actually tied into the solution itself. It's purely just to make Visual Studio aware of where it gets deployed and what window it should open in Internet Explorer when we start debugging from the F5 button. The second question is, are we doing a sandbox solution or a farm solution? So if I tell it it's a sandbox solution, it will actually stop me from compiling code that will not run in the sandbox. For now, I'm just going to say farm solution and finish. All right, so while that's working, I've got a question is, can we modify master pages in Office 365 SharePoint, including the style and position of the navigation menus? If yes, should this be done in Visual Studio 2012 or through SharePoint Designer? The answer is yes, you can do it, and yes, you should do it through SharePoint Designer. When you're customizing and doing branding, and there's a whole week dedicated to branding in the full version of this course, SharePoint Designer is one of the go-to tools for coming up with the design. Yes, I'll bring it back to Visual Studio to package it up for deployment once it's ready to go out to production. But in the case of Office 365, where you just have production, you can quite happily go in, create a master page, and edit it there in SharePoint Designer and achieve the same results. Okay, so Visual Studio is now here, and I've got my SharePoint project. So a few things worth noticing here is I've got a folder for features. I've got a folder for the package as well, which is the WSP. I can open that up and see the what's called the package designer. Now this is going to let me choose what parts of my solution get included in my package, additional assemblies that aren't part of what I'm compiling, as well as any other details that go into the manifest that it's generated for me. Another question is, does Visual Studio have to be installed on the server to follow my demo? For the stuff that's going in for this week's demo, it is all designed to be run from the server. It's all server-side code. The remote options for Visual Studio 2012 and SharePoint development are all around the app stuff. So we'll be touching a bit on apps with web parts next week, but mostly in week 4. So this week, if you don't have a server to be able to run SharePoint and Visual Studio up on, it is going to be a largely sort of theory week. Okay, so there's the package designer, and we can include items in there, and I'll show you a slightly better filled out version of that. So here's the code samples that I've published for this week, and you can see here I've got a few different types of projects attached in here. I'm just going to run through some of these and show you guys what's happening. So the first couple are just console applications, like I was demonstrating the code for. Now here I'm just opening my site and basically writing some information about that site out to the window and then finishing up. Now you'll notice one of the things I'm doing here is I'm declaring my site up here, creating the object down here in the middle, and specifically calling out my dispose method on the web later on, and my site object further down here. So the reason I'm doing this is because I'm accounting for the fact that errors might occur. So I've got my try-catch loop here and a finally statement where my site.dispose sits. Now, if I didn't have this and I created my SP site inside of a using statement and something went wrong, there could be a scenario where, in theory, the site doesn't get disposed of and a memory leak is created. So here is a slightly more complicated way of making sure that we're disposing while still working within a try-catch scenario. I'm just going to set a breakpoint on this first line here and press F5 to open up my application. So you see my console app has opened up, and here's my debugging environment for SharePoint. I can just use F11, sorry, F10, stepping through, and just stepping over line by line, seeing what's happening, and flicking back out here, you can see it's starting to output some of these parameters, but it's just the same rules as debugging any other style of .NET application. I've got my locals window, I've got my call stack, I've got all the same tools at my disposal. It's all very similar there. So if I just F5 and let that run out, you see that the rest of the code runs and it's finished. Questions there, do I need the dispose in the catch block? So I've got my dispose down in the finally block, purely because what happens with try, catch, and finally is that whatever's in the finally statement will execute after, if the try one runs successfully, it'll run at the end of that. If the catch loop runs, it'll also run the finally statement after the catch code is run. So this basically means that it'll run in all scenarios. Another question is, shouldn't I also do a check finally to dispose of the web object as well? Technically speaking, I could be doing that, yes. In this scenario where I'm just reading a property, I'm being a little bit on the lazy side and not anticipating an error there. But yes, the question is correct. If something went wrong in that statement and I'm not catching my error, there's a web object here that isn't getting disposed of. But there's just a really basic example of a console application. Now, the next example that I've got in this week's code is around logging. So here's another program here, which is just a very simple one-line console app, which is passing a custom message out to the ULS. So at this point, I'm going to go and open up that tool I mentioned earlier called ULS Viewer. And so here's ULS Viewer, and I can say I want to go and open from the live ULS, which it'll pick up the directory for by default. And what happens if I leave this going is it'll just start telling me everything that is rocking up inside that ULS log. Now there's a lot of data that's going to hit out through here. Now in the case of my custom code, I might have a custom category that I've got set that I want to make sure that I'm catching things for. So I can use my little filter button up the top here and say I'd like to filter out to a category that contains CSU dev and filter. And at the moment you see that there's nothing there. So now let me just close that window and flick back here, F5, and run my little console app. So it spins up, logs a message, and if I come back over here, you see here's my message in the ULS logs. So which process it came from. So this will usually be that W3WP worker process, but in this case it was my, my Visual Studio host, Xe. The thread that it came from, product I've left unspecified, but the category I'm able to specify in my code, the event ID in my code, the level, and the custom message, including the time that my log was created at. So this is all done through here, saying here's my category, here's my severity, and here's a string.format for my my actual message, and also a custom event ID as well. So we can use this throughout SharePoint, throughout timer jobs, throughout server-side code, throughout console apps that are running locally on the server, and create custom messages that go to the ULS that we can then easily pull back out. And they also then get controlled by the default logging settings within SharePoint as far as disposing of old logs, turning logging settings up and down, and that sort of thing. All right, on to something a little bit more detailed, an imported solution package. So one of those project types gave me the option to import a site template. So to create a site template, this is done through going back to SharePoint into your site settings for a, let's use the team site example, into my site settings, and you'll see that I've got a link in here that says save site as template. So what I can do in here is come and say my template is the file name, give it a display name, Brian's cool template. I can optionally include the template, the content in the template as well. So this can mean that any documents in document libraries and list items and things like that get included in the template. If I leave this unchecked, I'll get all of the structure, so my lists and my libraries and that sort of thing, but there won't be any content in them. But I'm going to click OK on that. And what SharePoint is doing is not liking me this evening. Right, so back to 365, and I'll show you this in here. Now what I'm going to do over here, so from a SharePoint site that's been created is site settings, save as template, just test and test for the sake of speeding this up. So what SharePoint is doing at this point in time, and you see this little working on it thing up here, is it's actually building a WSP package for me that's going to include the template, all of the features, the content types, the lists, the items, and saving that all into a WSP for me that I can now download and do something with. So after that finishes, you'll see it'll pop up here and it says, yep, go and check out the solution gallery to download it. So here is now my test. But if I click on it, it'll ask me if I want to go and download it. And I can save it and import it into Visual Studio. Once you go through that import process, you end up with a package that looks something like this, with a number of features automatically defined with a very generic numbering scheme. The package has been already set up and configured to have all of your components in it. So you can see here a very long list of everything that is in this, this particular package and the features that it's using. The main thing to look at here, though, is the web template. So here is my template called TeamSite. Inside of this, I've got this file called ownit.xml. All right. So what this is it's a big chunk of XML which is going to define what gets done inside of my site template. The things worth highlighting here are these elements called site features and web features. So features are all declared by GUID. And this is saying if it's a site collection, these are all the features that should be turned on. And here's all the web features that get turned on every time this site is created as well. So keeping in mind that features get targeted out to different scopes. So in this case, when we go and we create it, all of the features specified in this file will be turned on in the site. And each of these features might be doing things like provisioning a list, adding data to a list, provisioning pages, changing settings, executing code, that sort of thing. So we can get quite detailed in how we're going to go about building out these site templates. It's coming back in to look at the second file in here, my feature elements file. There's a bunch of properties about the template itself that are included in here. Of most interest is the base template name here of STS and the base template ID of 1. So these are what correlate your template back down to a site definition in SharePoint. Now the site definitions are deployed on the file system. So let's go and actually have a look at what SharePoint looks like in the file system. So if you are unfamiliar with where everything goes when you install SharePoint, it's under C, Program Files, Common Files, Microsoft Shared, Web Server Extensions, and 15. So this is the SharePoint 2013 version. SharePoint 2010 is under 14. SharePoint 2007 is under 12. But basically, this is the actual file system where everything gets deployed out to. Now, you'll doing server-side code, you'll get to become fairly familiar with what goes where in this, and Visual Studio does a very good job of sort of keeping you away from most of that and just knowing where things go for you. But looking under the template folder under site templates here, you see these are all the out-of-the-box ones, including STS. So this was the one that was there previously. And inside of here is, again, an ownit.xml file. So outside of having a couple of extra sections like these document template ones, the structure is much the same in that you have your site features and your web features, and this is how the out-of-the-box ones do it. But there is also a collection of XML files that gets stored up in the 1033 XML called WebTemp files, which are essentially an index of all the site templates that are available. So looking under here, you see STS was the template, and the configuration ID was 1. So my particular one in that case was based off blank site. So there's a good link in the documentation, in the links that I've shared for this lecture that goes through all of this in a lot more detail than I'm covering off here. But these are the key files to keep an eye out for when you're going through looking at site templates and site definitions. Okay, another thing worth coming back to look at, assuming my my environment feels like playing nice, is the developer dashboard. So I mentioned that earlier. Here's my little icon up in the top right-hand corner for my developer dashboard. And if I click on this, you see I get a pop-up window with a bunch of structure. But what I'm going to do is just start clicking around on some things. So show me site contents and show me the style library. Flick back over here. You'll see what's happening is it's tracking a number of the requests that are happening and the URLs that they're going to. So I can keep track of what's going on here. Now for each of these requests, I can see the time, the duration of the request, I can see the server that it hit, the client IP address, I can see the correlation ID. This is actually useful in the ULS logs to be able to filter down to a specific correlation ID. So if I copy that, flick back over to ULS here, and change my filter to say where correlation contains like good, I get all of the data from the ULS that relates to that specific request. Now, also in here we've got scopes that get defined. So this is great for helping identify slow loading parts of a page. So you can see the start time and the duration and the CPU time of each individual stage here. And so where all the heavy lifting is being done. I can have a look at the SQL statements and that got executed here. So you can see that just for browsing a document library, there is actually a fair few SQL statements that will get thrown out. SP request objects. So these are essentially objects that should be disposed of that are existing at the moment. Service calls and ULS. Now, I showed you before using ULS Viewer. One of the things we can do with the developer dashboard, oops, go back, is get the ULS right here from the developer dashboard to do with that specific request, which again makes it much easier to be able to go and turn this sort of stuff out. Questions come in is what else is correlation ID used for? You'll quite often hear people throw correlation IDs around when you're trying to diagnose errors, in that if you cause an error inside of SharePoint, more often than not, you'll get a generic little error screen that says something has gone wrong, but it will have a correlation ID on it. Every single request through the web browser to SharePoint has a correlation ID, and it's the way of grouping together things within a log that were to do with that request. So the correlation ID is quite important when you're trying to diagnose things from what happened when I browsed to this page and getting out the logs and data for that specific page, or when an error happened, getting out the logs to do with that specific error and what happened when on the request that caused that error. But that's the developer dashboard, and a very, very useful tool it is. So other things I wanted to have a look at really quickly is the SP dispose check. So coming back to having that installed, and again there's links in the documentation for this, is it runs out of Program Files, Microsoft, SharePoint Dispose Check. So what we've got in here is our SP Dispose Check exe, and just an examples one that throws some errors. So if I call SP Dispose Check, and pass in this path, oops, I need to put quotes around that, sorry, is you'll see it runs up and starts doing a check, and what we'll get spat out here in a second is saying that there were 4 modules checked and 19 total memory leaks found. And as we scroll up here, we can start to see the individual an ID of something that's gone wrong, which module it was in, the method that it happened in, the where the source code is, and the line number of the source code, saying there's a disposable object type that wasn't disposed of, being an SP web. So it gets quite specific in what's going on here as far as telling you where there's potential for memory leaks. Now, as I mentioned before, I haven't actually personally had a lot of luck getting this to work for .NET 4 compiled stuff yet. I'm still chasing down what the response there is. There will probably be an update to this particular tool in the not all too distant future, but just worth having an awareness of, because it is quite a useful tool to be able to integrate, and you can integrate it into Visual Studio quite easily. If I go to my Tools menu and down to External Tools, you can actually list it in here by saying, here's the command of spdisposecheck.exe, and to pass in the target path so that I can run it on a project from Visual Studio and get the output directly from what's going on there. Now, the fourth of the demos that we had tonight was a Sandbox solution of all things, but it's actually used for deploying a list. Now, the full instructions on how I got this list created are in the lab guide, so you can go through and do this yourself. But you see I get a nice little designer for putting together the columns that are in my list and what's going to be required. I can get specific with content types. I can create my views for the list and specify settings like its title, its URL, whether it gets shown on the quick launch, and we get quite a nice little designer there. But inside of here, you can see I have a feature for my list. So what I'm going to do is I'll open this up and show you that there are three things in this feature. There is my site column. I've got a custom site column. So the first one here, if I open this up and have a look at its XML, is we're creating a site column called member type. It's a choice column, and here's the choices, so it's a drop-down. So we define that in the XML. We have a list definition, so this is a template for a list. So when I create a list off this definition, it will look like the following, and that's where that designer came from. And the last is a list instance. So basically we're saying provision me an instance of this list. So, and I've just accidentally taken that out there, and I don't want to do that, so I'm going to roll that change back later, but we're including that. So that's all documented in there for you guys to be able to go and create. Now, one of the things you saw there with that XML of the site column is that it is a fairly specific type of XML and can be difficult to hard code. Again, there are ways that we can export this sort of thing, and exporting a site template is one way, but there's another tool that I wanted to show you called SharePoint Manager. So what SharePoint Manager gives us, and it's a brilliant tool for developers, is a hierarchical view of everything that's happening from farm down to the servers in the farm, the individual services, my site, down to my web apps, my site collections, and then within those, the individual sites, and then browsing down into that, here's my intranet site. You can see on the right-hand side here, I've got the full properties of every one of these objects from the object model and being able to see what the current values of everything is. But I can come down to my site columns here, which I refer to as fields, which for some reason I'm not displaying in this one. I'm going to have to restore it back up. But come down to my lists, see my lists, see my documents, and come down in here and see items. And so there's an item in a list and all of its properties there. So it gives us a great way to be able to go and get some of this XML. So if I come back up to the list, for example, I get a tab called Schema XML, which actually shows me the camel for that particular list. And in here you can see the field elements for choices, and it's that same format of XML, so we can use it to pull it out that way. So very useful tool for being able to reverse engineer things out of SharePoint. All right, so other things I wanted to show for the Office 365 people, flicking back here, is my developer site. So I mentioned earlier the Napa tools for what we can do with SharePoint development through the browser. If you create a site based off the developer site template, and it's very important that you make sure it's the developer site template because it will not work in any other site, we can come in here and say build an app. And what that will do the first time you run it is it will install the Napa app into your developer site. Once you've installed it, you can click on this and it'll bring you back into Napa. So it brings me off here to napacloudapp.com is the URL. And you can see I've got SharePoint App 1 here. So I'm going to click on this and open it up. So you see here I've got a code editor, and I've got my structure here of my content, my images, my CSS, my JavaScript, all this sort of stuff that's getting packaged up into my app. We'll go into the app structure stuff in much more detail in week 4, but just worth knowing that this is all here to be able to play around with. Is just kind of incredible for what you can do in the browser. Now, say I'm ready to go and run this. I've actually got a little run button down here that runs the project. And what it's doing in the browser here in the cloud for me is it is packaging up my, my app. You can see now it's uninstalling the previous version from where I'd run it before. It's then going to go and install it for me and then open it so I can go and test my app. Again, all entirely within the web browser. So the question that just come through, how can I get the slides? So again, all of the slides are in the IT Masters portal there. So the learn.itmasters.edu.au. So you should have a link for that after registering, but that's where all the content is. And I've just had a pop-up window here, showed up on my other monitor. There's my app. It says, hello, Brian Farnhill. So it's using some JavaScript to pull out my name based on the context data inside of SharePoint. Another question, is it important to know when your code is performing a synchronous or asynchronous call to SharePoint? For the server-side object model, it's all synchronous. There's nothing asynchronous going on there. It's all completely sequential. And the client-side object model is basically the flip of that. It's important to know purely from it you'll need to code to handle those particular responses coming back from those different types of asynchronous calls. But generally speaking, in server-side object model, it's borderline irrelevant. But so say I'm finished with that, I can go back from Napa back into my Office 365 site, and you can see SharePoint App 1 is deployed in the site here, and it's done. So there were a couple of little things that that I wanted to just touch on really quickly because we're pretty much out of time. One of them is SharePoint Designer. So I'm just going to open that real quick and just give you a quick look at that. So SharePoint Designer will work remotely. It doesn't need to be on the SharePoint server. You can run this up on your desktop and access any kind of SharePoint site. What I'm going to do here is I'm going to open a site. And open. So SharePoint Designer gives me the ability to go and customize a lot of stuff in here. So the obvious one is the design-related elements, like your branding, your master pages, and things like that. And you can see down the side here, I've got specific views into the master pages and the page layouts. But we can also do things like manipulating lists. So here's the lists and document libraries from my site. I can create and manage workflows, so list workflows or reusable workflows, site workflows even. I can look at external content types. So this is the BCS stuff and accessing data that's external to SharePoint. I don't have any of them deployed at the moment. I can manage my site columns and content types and create new ones in here. And I can also look at groups and permissions and just the whole file structure. So it is quite a useful tool for being able to manage and manipulate and work with SharePoint content. So that's about the gist of what I wanted to run through in the demo here. Couple of last questions that popped up during that bit there. When using the MVC model, isn't that asynchronous? It all depends on how you're writing your code, really. Yes, there's a separation between your model and your views and your controllers and that. You don't necessarily have to be asynchronous in MVC. It's a model that lends itself towards that, but yeah. Is it possible to get the video recording? Yes, the link to this video recording will be posted a little bit later tonight after it's been processed and uploaded. So again, watch that portal, the learn.itmasters.edu.au portal, and you'll be able to get the link to watch the whole thing again. And the last question is, would incorrectly modifying the webtemp.xml break SharePoint or stop it from running? So a very important point here, and I'm glad somebody asked the question, is modifying any of the files that SharePoint puts onto your file system is completely 100% unsupported. The reason for this is that if you make changes to something to get your solutions working, there is no guarantee that they won't be replaced by a service pack or something later on. Also, if you call Microsoft and get onto Premier Support and ask them for help and tell them that you've modified some of the file system files, they will basically give you a pat on the back, wish you best of luck, and let you go and figure it out on your own. So it is very, very important that you never edit any of the out-of-the-box files. Now, if you're provisioning your own webtemp file and you get some of the formatting wrong, the worst that will happen is your template won't show up for users to be able to select. It's not going to cause SharePoint to fall over in a heap. There are very few of those files that will let you deploy as a solution that will cause SharePoint to fall over. One of the things that happens when you deploy your WSP package is SharePoint actually does a validation of all the XML files, like your feature manifests, your solution manifest, and all of that. to make sure that the XML is valid against SharePoint schemas. So it will stop you from deploying something that is really horribly wrong. So it'll look after you there. So that basically brings us to an end of tonight's lecture. I've sort of run a couple of minutes over, and I apologize for that. So here's the portal worth looking at here. So here's all the content for week 2. I do have quite a lot of reading prepared for this week based on all the topics that we've gone through. Some of these pages on SDN that I've got are just links off to a few other pages that are relevant, so please read through as much of this as you can. I will be picking lots of this out to be using in the exam at the end, so make sure that we study up on this. I've got source code here at the bottom for the zip file for anyone who wants the completed code. And anyone who's familiar with Git who just wants to take a fork of the GitHub, I've got the link at the top there, and it's all published and publicly available on GitHub for you to be able to go and grab a hold of the code for. And apparently my session expired there, but here's GitHub when it wants to open for me with the code for what's happening here. So I've got the week 2 examples here at the moment. Week 3 and week 4 will come as we go forward through there. So, so that brings us to the end of the evening. Thank you guys for participating in the live lecture. I appreciate the questions, and I hope you guys got something out of it. Please make sure that you start up discussions in the forums if you've got questions or you're having any issues with what's going on throughout the week. I'll be monitoring it closely and be available to help out. But otherwise, enjoy playing around with SharePoint, and thank you for watching.